Hi Year 9s and welcome to this special video for your Digital Delivery Day. We are covering the beginning of a new topic which is called statistics. We'll say a little bit more about what this is, and our focus in today's class is classifying data and representative data. Your old teachers may have written up success criteria for your classes, and since we are in a different format than usual, I want to be really upfront on what I want you to be able to do at the end of this class. So I want you to be able to classify data as either categorical or numerical, and either nominal, ordinal, discrete, or continuous. And if I give you a sample, I'll define what that is later, I want you to be able to tell me if it is representative, yes or no. So without further ado, let's get underway. I'll say more about the homework at the end of this video. So, statistics has a reputation for being a very, very dry topic. It certainly puts a lot of high school students off the subject. I come at it from a different angle, mainly because I used to work as a statistician before I became a teacher and came to Nossal. Statistics is all about telling stories with data, and stories should be interesting to all of us. You can pick any question that you like, anything that interests you. You have a question and you want to get answers. So what you do is you collect some data, and once you've got everything, you're going to need to do something with it in order to answer your question. And what we're going to do today is ensure that the data that we collect represents the wider population, the entire group of people that we are interested in. And secondly, in order to be able to analyze data, a very useful thing to do first is to classify the data, because that's going to determine what kinds of analysis you can do. So we're only focusing on two very small aspects of a very wider process, which is picking an interesting question and trying to answer it. And as far as I'm aware, you're getting some exposure to this in your Year 9 project that you began collecting data for during your city program. You're getting some real insight into all of this, and in MATS, we're going to spend a little bit of time on analyzing data and whether we have collected data in a way that's representative. So we'll spend most of our time on classifying data today and make some brief remarks on representative data. And then the rest of this topic will be mainly about analyzing data, mainly calculating statistics and generating graphical displays of that data. So, classifying data. This is our first goal for today. We're only going to consider two main types of data today, which is called categorical and numerical. You might have met these labels already in previous study. We're not worried about interview data or open-ended questionnaires where respondents give long responses in sentences and paragraphs, essentially. That's sort of beyond the scope of a maths class, but that's not to say that that data isn't important. It's very important. Often that data is very rich, but it's harder to summarize. It's much harder to do that. So we're going to look at simpler data today. So assuming that we are only looking at categorical and numerical data, which I will define in a moment. So just with the data that we will give you, we're going to make some distinctions. So what I've got on this page is a bunch of questions that you can ask, some decision rules that will help you to classify that data. So the first question that I want you to ask is, given what I have, does it make sense to calculate totals or averages with that data? If the answer is yes, then we say that the data is numerical. That should make you think of the word number. And if the answer is no, then we say that the data is categorical. Now just be careful, not all data with numbers is numerical. The key thing you want to look for is whether you can calculate totals or averages with those numbers and whether you can interpret them in a way that makes sense. So, assuming that we have numerical data, the next question that I'll ask is it possible to observe any value, any number? If the answer is yes, we're going to define that data to be continuous. If not, then we're going to say that the data is discrete. So that means only specific values are possible. More examples to come in a moment. If your data isn't numerical, now I'll ask the question, given my categories, given my names, given my labels, is there a natural order or hierarchy to them? If the answer is yes, we're going to call that data ordinal. And if the answer is no, we're going to call that data nominal. So the way that I usually explain this to students to help them remember this is if you see the word ordinal, that should remind you of the word order. Ordinal data can be ordered. Nominal data cannot be ordered. So if you haven't seen this before today's class, I encourage you to write this down somewhere where you can refer to it. And on this next page, I just expand on this in a little bit more detail. So the detail comes when looking at discrete and continuous data. So generally, if you can count your values to get your observations, we're going to call that discrete. But if you can't count it, usually because you're taking a measurement, that data is going to be continuous. So can I count it? If the answer is yes, discrete. If the answer is no, it's continuous. All right. Assuming that you're comfortable with this, I'm going to set an exercise for you to try. So what I'm going to invite you to do, Year 9s, is to pause the video on this page and have a go at the two exercises that are listed. And the beauty of this video is you can scroll back, rewind, and check the previous 2 pages to help you make your decisions. So I've given you 8 questions to have a go at. So just take a few minutes to pause the video now, and then the answers will appear shortly. All right, so hopefully you've had a go at these 8 questions. And now I will briefly discuss the answers. So here are the answers. First of all, temperature. The weather forecast will often give values such as 18 degrees or 19 degrees. But I can have any temperature I want. I'm just limited by the precision of my measuring instrument. When I say the temperature is 19 degrees, what I really mean is the temperature could be anywhere between 18.5 and 19.5. I've simply rounded that value. I did a measurement, but my measurement only had a finite precision. So since I took a measurement and I couldn't count the temperature, it's continuous. And it does make sense to take averages of temperatures, say across a week or a month, and that's my justification for saying that temperature is a numerical variable. For question 2, suppose that we have subscribers to a YouTube channel. We can add up those numbers across multiple YouTube channels if we want to, so it does make sense to calculate total, so it's numerical. But this time, only specific values are possible. So I can't have 1.5 subscribers. I can only have 1 subscriber or 2 subscribers. So for that reason, it's discrete and not continuous. For number 3, same reasoning. The thing to bear in mind is, with money, it's measured in dollars and cents. And we can't have parts of a cent, at least in a bank account balance. So only specific values are possible, and therefore it's discrete. For question 4, the 100-meter sprint time. What usually happens is someone has a stopwatch, the person runs, you press start and you press stop. The stopwatch has limited precision. It might say 10.1 seconds, but really the time could be anywhere between 10.05 and 10.15. So for that reason, with a time being a measured value that we can't count with finitely many values, we consider it to be a continuous variable. For question 5, there's a clear progression, a clear hierarchy, a clear ordering between the ratings from low, medium, and high, and so that makes the categories ordinal. There is an order to them. For question 6, country of birth, there's no natural ordering to all of the different countries in the world. So with no ordering, we're going to consider this a nominal variable. For question 7, similar to question 5, there is a clear progression from disagree to agree. So there's an ordering, so that makes this an ordinal variable. And the very last one might surprise you if you haven't done a question like this before, because you might think, oh, postcodes, those are numbers. For example, I'm just trying to think. My hometown, Hampton Park, about 20 minutes from Nossal, has the postcode 3976. I could take people's postcodes and surely I could add them up or find averages. But the problem with doing that is there's no reasonable interpretation for a total postcode or a postcode of 3976.24. So for that reason, even though there are numbers, because we can't make sense of the totals or averages, we actually consider postcodes to be a categorical variable. You might also be interested in the question of whether postcodes are considered to be nominal or ordinal. And if you look online, you'll actually see that there's a bit of a debate about this. Well, I should say, you can argue for both. So that's why I haven't committed to giving you a particular answer there, because you could argue either way. I invite you to have a think about this or read this up yourself. So, last thing before I let you all go. So, assuming that we have a way to analyze data, that's great. We're able to analyze data because we've classified it. We'll teach you how to analyze data soon. You've done the first step of classifying data, meaning that you can now decide what sorts of analysis you'll be able to do soon. But before we even get our data to do analysis, we need to make sure that we're collecting data that's going to be useful. That is to say, if I have a population which is a massive, large group of interest, it could be all of Australia. It's not going to be practical for me to walk up to every person in this country and ask them my question of interest. So what often happens is we ask a smaller subset of the population, a smaller group called the sample. And what we're hoping is, even though we couldn't ask every single person in the population, if we ask a well-chosen sample, we'll be able to learn something about the population. And two things that we need. So number one, we need to make sure that our sample is large enough. I'm not going to learn much about Australia by asking 5 people. There are some technical details about how we choose a sample to be large enough, and I'll leave that to your VCE and university teachers. The one we're interested in today is the question of whether the sample is representative. That is, does it reflect the characteristics of the population? If it doesn't, then we say that the sample is biased. But if it does, then it's representative, and we're hopeful that our data collection exercise is going to be useful. So classifying data is the main focus of this lesson, and we just want to briefly mention this so that you're aware of the issues surrounding this in case you go on to do more study in the area of statistics, or if you become a researcher in the future, which some of you will. So to finish, I've got 3 short case studies for you. So what I invite you to do once again is take a few moments to pause the video and answer this question. In each scenario, is the sample representative? If yes, great. If not, give a reason why. So just pause the video now and see if you can come up with some responses to these questions. Okay, so hopefully you've gone away and had a quick think about these 3 case studies. Here are the answers, and the aim is not to try to trick you. We just want you to begin to develop a sense for non-representative samples, because without being taught this, it's easy to miss this. So what's wrong with Toorak? Well, if you know the way of Victoria and Melbourne well, Toorak is a very expensive suburb. And so if I only ask homeowners in that suburb, I'm not going to get an accurate representation of all of Australia. So we should look at sales from a variety of suburbs. All right. When I was younger, Toorak used to be the most expensive suburb in Melbourne. I don't know if that's still true. Feel free to tell me the next time we meet in person. Okay, case study number 2. I always enjoy playing this joke on my students that the school's considering changing the color of the school uniform. So let's just ask 1 year level. Well, what's wrong with that? Well, everyone else is going to want a say too. So the year 10s to 12s are not sampled. Only the year 9s are. So you're not going to get an accurate representation of the views of the whole school if you only ask 1 cohort. So we should include them in our sample. All right, last one. I want to find out the most popular sport in Australia, and I'm going to accomplish my mission by turning up to an AFL match and asking random people there. Well, what's wrong with that? Well, you're going to probably get a biased opinion from the people you're asking, they're all going to be AFL fans. You're more likely to get an answer, a dominant answer of AFL, because you've gone to an AFL event. So I'll say the audience will have a preference for AFL. How could we improve this sample? There's many ways to do this. All of them have their drawbacks, but perhaps you want to ask people outside the context of a sporting match and ask a variety of people. So maybe consider asking a greater variety of people. In different contexts. It's actually really hard to develop a sample that is truly representative. Most survey designers and professional statisticians accept that there will be a small amount of bias in every sample. So we can't eliminate it by virtue of the fact that we are not asking everyone in the population, but we can seek to minimize it. In these 3 case studies, there is a clear issue. So I just want you to see what the issue is and to be able to propose a solution. So that's all I wanted to share with you today. So here's what I would need you to do before we meet again next Monday. I will direct you to the unit outline, which is posted in OneNote, and we have now covered the first lesson. So that means your homework is to complete the first exercise. And if you've followed the video, you should be prepared to do the questions in the exercise. So just questions 1 to 6 and 8 to 10, and for both standard and advanced. Okay, so everyone's doing the same questions. If you need additional help with this material, there is a PowerPoint available, and there's a textbook that you can read as well, the PDF, or through Cambridge. So, thanks for your attention, Year 9s, and if you need help with anything, feel free to get in touch with your teachers over Teams. See you next Monday.